Hello everyone. I'm Anton Borisov from Fresha. We are pushing boundaries of data engineering and innovation, doing it literally every day, usually after lunch. Today, I'm thrilled to share our journey with you, a journey of transforming how we work with analytical data with introducing StarRocks, probably the first ones in the UK. Yep. So let's go to another slide. This is our agenda. In the next 20 minutes, I'll show you how to serve StarRocks with class and style, like a favorite whiskey dram, drawn from real-world challenges we've tackled at Fresha. Whether you're optimizing query performances, scaling your analytical infrastructure, or building robust data pipelines, I'll share some practical insights that can elevate your data engineering stack from just functional to an exceptional one, with the help of StarRocks, of course. I mean, why we are here, after all. So let's dive in. Yep, this is our previous data architecture. The introduction was very promising and cheeky, don't you think? Now let's take a look at something that was working, but a bit unamusing. Maybe I even call it depressing. God save me from these furious fresh analytics. This was our previous stack. Take a look. We had over 100 Postgres databases powering fresh operations. We used CDC to stream everything into Kafka with our good fellows Debezium and Kafka Connect. Then pushed it all downstream to Kafka topics, Postgres, and finally our biggest friend Snowflake. Now I'm deliberately oversimplifying here. I'm skipping over our beautifully crafted deduplication pipelines. Another pipes that I called snow pipes, somebody knows about them, Terraform configurations, DBT models, airflow schedules, and countless optimizations scattered throughout this architecture. Don't get me wrong, it was brilliant engineering, truly. But I'm here to talk about StarRocks, not to give you a masterclass in complexity management. And here are the things that it was working until it wasn't. So, pain points. Snowflake isn't really real time. We are talking about 5-10 minutes delays in serving complex models at best. And the costs, let's just say that our head of data engineering, hello Emiliana, I know you're here, starts the usual day asking uncomfortable questions about our cloud cost bills. Running analytics on Postgres, sure I can do it, it's real time, but it's a lot, it's OLTP. Every heavy analytical query was affecting our customers directly, and with buffer cache, churn was actually a big deal, and it was killing the performance. Our transforms were super thin, no real joins, windows, or enrichments until data reached dbt or Snowflake. Let's actually take a look at some picture, because I think like it would be easier to embrace what I'm talking about. So we were essentially shipping raw data everywhere and transforming it multiple times downstream. Recovery from outage, heavy slow snapshots and backfills that could take hours or even days to rebuild our analytical views. Flexibility, forget about this. There are two chairs, Snowflake and Postgres, Can we do better? Well, if you're up to the challenge. And that's where we need to change the tune and look at the new data engineering architecture with StarRocks. So, what I are seeing now is actually a new data engineering architecture. It looks a bit the same in some parts, but what we left? Source planes. Our Postgres database is streaming through Debezium and Kafka. That foundation was solid, so we kept it. But here where things get interesting. We added a dedicated compute plane with Spark and Flink. This is actually crucial. We are no longer locked into scene transformation. Flink gives us a stateful stream processing with exactly one semantics. Need a streaming join? Complex windowing? Real-time aggregations? Flink handles it before data even lands. Spark tackles the heavy lifting. Backfills, historical reprocessing, complex batch pipelines. We finally have the flexibility to transform data where it makes sense, not where we are forced to. Next, the lag plane with Iceberg and Pymon and Lakekeeper catalog. Hello from, I guess, to our friends from Wakama. This isn't just cold storage, it's active infrastructure. Iceberg gives us reasonable read performance on prepared data. Pymon is even more interesting. It's built in for streaming. Flink pipelines do lookup joins directly against Pymon tables, enriching streams with dimensional data without hitting production database. Big win. The lake is no longer where data goes to die in some cold storage and analytical stuff that run once a day. It's where it goes to live differently, with different partitioning schemes, with different requirements, with different filters and other stuff. So you know this. And then we have finally the serving plane. And this is where the most elegant part, StarRocks, isn't just another OLAP engine we bolted on. It's a sophisticated federation layer that stitches together our entire data ecosystem. Think about it. StarRocks connects to Elasticsearch for text search, Postgres for operational lookups, Iceberg and Pymon for historical data, and serves its own internal format for hot data. From the user perspective, it's just a SQL. One query where you are searching, whether you are searching the logs, joining real-time metrics, or analyzing 3-year trends, or doing it all at the same time. You can do it. Don't know why, but yeah, why to limit yourself? Okay, so StarRocks. StarRocks is cool. I mean, like, you've probably seen this picture multiple times on this conference on the StarRocks site. So basically, it's separation of compute and front-end storage, distributed storage with federation abilities. So let's just skip to another slide because, I mean, like, probably you can know a lot from other sources. So this is more interesting. Why it's so great? Remember those pain points that I mentioned? Snowflake's latency and cost. They're actually gone. StarRocks internal format gives us sub-second queries on hot data. Historical data stays cheap in the lake, accessed only when it's needed. Postgres analytics skill in production, solved. Analytics runs on StarRocks. Sorry, Snowflake is not the right name to use here. Analytics runs on StarRocks, not on your transactional database. Buffer cache is happy, customers are happy, well, me happy too. Scene transformations, fixed. The compute plane handles complex logic before data even lands. Flink does streaming joins and aggregations. Spark handles heavy batch processing. Recovering nightmares? Remember those painful backfills that I described? Now Spark rebuilds historical data in the lake. StarRocks refreshes its materialized view. Oh, not. But I mean, like, materialized view is the most common thing to accelerate. And we are back online. No more pain over slowly recovering snowpipes and kind of like waiting for the backfill or snapshot to finish. Flexibility? Well, we've got it too. New data sources added to Kafka. New transformation deployed to Flink or StarRocks. New access pattern, create a materialized view in StarRocks. Each layer does one thing, but does it well, and StarRocks ties them together. The magic isn't that we have all these technologies, it's that StarRocks makes them invisible for the users. In the end, you work with a unified interface while we handle the complexity underneath with StarRocks. That's how you serve it with class and style, by making the hard things look easy. Okay, let's jump how we run StarRocks. We've chosen to run on cloud native with Katies. Why we've done it? So simple. We run everything on Katies. Our entire stack lives there, so we wanted to push the boundaries with StarRocks too. The StarRocks operator gave us exactly what we needed: full control and understanding. We can see every pod, every resource allocation, every metric. Need to adjust memory? Boom, update the YAML. Need to observe performance? Datadog, our friend, is there as well. Just watch out. There are a lot of metrics from StarRocks, so we don't wish to push it all this to Datadog. Or Emiliana would chase you. Yep. Need to control cost? Autoscaler. In shared data mode, we only pay for what we use. Honestly, it's become boring. In the best way. Deploy, scale, update, rollback. It's all just works like any other Katie's workload. Our SRE team didn't need special training. It fits right into our existing CI/CD monitoring and alerting. There is a limitation. Well, I wanted to talk about this limitation, but basically it's no longer a case. I mean, like, it's still a case because we want sometimes physical resource separation. And it was declared right now, right today on this summit, that actually multiple warehouse feature would be donated to open source and would be available to just run as on Kubernetes as well. So we can't have separate tools for now for compute nodes. How we can manage with the things before StarRocks 4? Well, we partially solve it with resource groups. They provide logical isolation and work fine most of the case. Worst case scenario, spin up another cluster. It's not perfect, but at least it's manageable. If this becomes a serious bottleneck, we'd consider seller data. Yep, they offer exactly the kind of physical workload isolation right now, but I think we would just wait for StarRocks 4 and consider for when we are kind of like big enough to actually employ seller data. They're nice guys and doing a great job. But for now, we are running production workloads all on Kubernetes, boring, predictable, scalable, adjusted for our needs. So let's jump to the actual data-related questions because they're fun. So data paths. We classify four specialized lanes, all fed from a single source of truth. The ingestion spine remains Kafka division stream CDC event from the same Postgres databases using Avro and schema registry. This gives us strongly type available data that fans out to everything downstream. That works. That's cool. Real-time analytics. Flink writes directly into StarRocks internal columnar tables. We keep it deliberately short. Kafka, Flink, StarRocks, dashboards. No object storage in the critical path. We use primary keys tables for updates, aggregate key tables for pre-rolled metrics, and duplicate key tables for append-heavy streams. On top, we build materialized views that StarRocks Optimizer automatically uses to speed up queries. Result? Sub-second latency for operational dashboard. Yeah, that's cool. For historical data, we didn't abandon the lakehouse. We embraced it. Flink writes the payment, Spark handles Iceberg for long-term storage, but here's the magic. StarRocks connects to both through external catalogs. Your historical queries federate over open formats without ever copying the data. When backfills land in Iceberg, we can just refresh materialized view, making historical data as fast as real-time. Well, most of the cases, because materialized view wouldn't solve all the problems, but let's not focus on this. They're cool. Let's stop at this. For search workloads, fuzzy matching, relevant scoring, we index into Elasticsearch. But engineers don't need to learn a new query language, don't need to install and actually figure out how to ingest data in Elasticsearch. By employing StarRocks ES catalog, still in beta but works great most of the cases, search indices look like regular SQL tables that you can join with your analytics. So you ask the result, I answer like it's one endpoint that unifies everything, or one tool, whatever you like most. Engineers write boring SQL. The optimizer figures out when to hit internal tables, materialized views, lakehouse tables, or Elasticsearch. We run StarRocks in shared data mode so we can scale this compute without reshuffling the data, so it's great. Simple interface, complex implementation hidden beneath. Exactly how it should be. Okay, let's speak about data tiers now. And this defines what I call temperature data tiering used in StarRocks: hot, warm, and cold. Hot data is served using StarRocks internal format. This is where StarRocks really shines. Highly tuned caching, indices for filters, and the full MVP engine running at peak performance. Your most recent data, your real-time dashboards, your operational metrics are all blazingly fast in memory or in the on local SSD. Warm data covers your operational period, typically 1-2 years, but you may choose maybe 5 years. It's mostly static, but can still be modified. Sometimes we serve it directly from Iceberg. Sometimes it's a hybrid approach. Historical base is in Iceberg. Recent deltas is in StarRocks internal with the duplication logic. As data ages, we roll and expire to object storage. Simple. Cold data is immutable. Analytical data prepared by Spark with different partitioning strategies, different consideration. We use it for backfills and large-scale analytics that we usually do with Snowflake, but who knows? If a dashboard needs 3 years strength, StarRocks can reach into a cold storage through external catalog. You'll pay some latency tax, but come on, you just need it if you want to run large-scale batch analytics. The beauty? This isn't 3 separate systems. It's just one StarRocks cluster intelligently routing queries across temperature tiers. Your data naturally flows from hot to warm to cold based on age and access patterns, while your SQL stays exactly the same. I think it's cool. Okay, and now is the main part, I guess, that everybody are very interested. Let's walk through a real case study. Fixing our homepage analytics that we are literally bringing down our production. The problem: our homepage shows customer-facing analytics. Top employees with 2 months comparison, top services, top sales feeds, appointment, upcoming appointment. So all the crazy stuff that you basically wish to provide for the customers in the real-time dashboards, because yeah, they want to see fresh data. Why not? For small accounts, Postgres handled it fine. For our largest partners, well, 15-20 seconds page loads. Sorry. Sometimes complete timeouts. That was completely unacceptable, for homepage queries. And here's the kicker. It was destroying our LTP performance too. The failure pattern was literally textbook database pain. Cold cache, missed triggers, massive data scam. Okay, first request times out after 30 seconds of grinding. Well, most probably we have less timeouts. But okay, I think like it's 15 seconds, most probably. But I just use 30 seconds because it's more illustrative. Buffer cache gets obliterated. Next request succeeds in 5 seconds using now warm cache. But we've just evicted all the LTP data. Every transactional query slows down. Customers complain, engineers panic. I don't like it. Why not to use Snowflake? High QPS UI reads plus Snowflake concurrency model equals astronomical cost. We don't want this. We are talking hundreds of queries per second during peak hours. Snowflake would have bankrupted us if we've chosen that path. Okay, that's actually how they look like. So very sleek, very interesting once they load. If they don't load, well, it's just not nice. Okay, we tried to optimize Postgres, more indices, more query writes. P50 latency became acceptable, but P95 and P99 were still spiking up to 10 seconds. Buffer cache churn remained a problem. We were asking Postgres to do something it's not, a high concurrency OLAP engine. What we actually needed, sub-second reads with stable tail latencies, and crucially, minute-level data freshness. Users complete a sale, they expect to see it reflected immediately, not in tomorrow's batch job. Our first attempt with StarRocks used Iceberg for everything. Well, was it a stupid idea? Most probably, but we just needed to start with something. Functionally, it worked, but operationally, well, not a great success. Minute-level updates means constant small files. Compaction couldn't keep up. Query performance was unpredictable. Sometimes it was 200 milliseconds, sometimes 2 seconds, sometimes whole life. Depending on how many files needed scanning. The solution: hot data in StarRocks internal tables, historical in Iceberg. But here's the key insight. We didn't use materialized views. Instead, we built layered SQL views to hide all the complexity. It's actually pretty similar how demand base and handle this stuff. So I will tell you shortly. It's very neat. Oh, okay. This was kind of like how would you rate the session? Sorry, I got distracted. Let's get back to this. So let me explain why it matters. At the base, we have real-time sales. It's literally real-time table fed by a thing from our CDC pipelines. Updates landing with every checkpoint interval. On the top of this, we have like view sales enriched. This view applies all of our business logic. What counts as a valid sale? Which statuses matters? What are the commission rules? And other crazy business logic to qualify as a kind of like sales enriched. All encoded here with proper partition predicates and derived field-to-field joins and other stuff. So then we have recent sales view. That defines what recent means for different contexts. Last hour, last day, the business logic lives in the view, not scattered across queries. Finally, the presentation view. Top employees, 2 months for the 2 months comparison, top services for services ranking, and other kind of like use cases that I actually kind of like described when I mentioned the description of use case. Why views instead materialized views? 3 reasons. First, semantic reuse. Every team querying sales data uses the same definition of what a completed sale is. Change the business rule once, and everyone gets an update. Neat. Second, flexibility. Need a 3 months comparison instead of 2, create a new view in seconds, and it just works. Third, optimize intelligence. StarRocks pushes predicates and projections down through the whole view stack. If you only need yesterday's data, it only scans yesterday's partition and it goes through 3 layers of views. The implementation was surprisingly smooth. Flink reads from Kafka, writes to StarRocks internal tables with primary keys for deduplication. The view definition actually took only a single day to get it right. I literally did it after the lunch, and the main pain point was actually kind of like to handle MySQL client integration in a Rails application. Yeah, you know this problem. So, results. Let's take a look. This is kind of like some sample charts that I provided for you to make sense what we actually achieved. Let's be honest, results exceeded expectations. Homepage queries dropped from 15-20 seconds that I mentioned to 200 milliseconds. Sorry, it's not just P50, even P90 stayed under 300 milliseconds. Postgres buffer cache thrashing gone. OLTP performance returned to normal. Data freshness under 1 minute end-to-end. From database change to dashboard updates. What about costs? Fraction of what Snowflake would have been for this QPS. But here's the beautiful part. The same view definition works over historical data. Need an yearly trend? The view can federate to Iceberg through external catalogs. Same SQL, same business logic, just different data temperature underneath. So, what we've learned. Lesson 1. Don't force databases to be what they are not. Postgres is super cool doing OLTP. Let it do. StarRocks is an amazing OLAP. Let each do what it's best at. Second lesson. Views are underrated. They are not just SQL organization. They are semantic contracts that ensure consistency. We just demonstrated it. Third lesson. Hot, warm, cold isn't just about cost. It's about picking the right storage for the right access pattern. Minutes fresh data needs different infrastructure than yearly aggregates. This case study proves the architecture that we envisioned worked. We took our worst performing, business-critical analytics workload and made it invisible. Users get instant results, Postgres stays healthy, and we sleep through the night. So, what else I can mention about this use case? It's actually kind of like, it's another results, so it's basically kind of like structured a little bit, sorry. I got lost a little bit. So, adoption. I want to speak a little bit about the adoption. We have PG, how to enable developers to adopt it. So, this is schema migration tool. Developers got used to migration, online or migrations. So that's how we handle it. So it's basically resembles a little bit Rails. So you can take a look. So we delivered like GHA automation using CLI. Then we have schema sync tool. And then it's our new roadmap. So we want to scale our new architecture. We want to use Plus. We want to look at the auto queue and even and all other interesting things. So I want to present you a team behind this. So it's Nicoletta, it's Samuel, Emiliano, Peritos, Piotr, and Emil. I want to leave a heartfelt thank you for this team. And it's also me, the guys that envisioned this architecture, and you made it. So if you like to hear more stories about this, subscribe to Data Engineering channel, and we are eager to tell you more about more interesting use cases.
Perfect. Thank you very much, Anton. This is really fantastic. I love the presentation. I'm sure our audience did too. I know we're basically out of time for the next session starting right now. But if there are any questions that people have that need to get answered, there is a Slack channel that's dedicated to Summit questions. And if you have a question related to this session, feel free to bring it up there and we can connect you with Anton to get an answer. But in the meantime, thank you again, Anton, for presenting, everyone for attending. This has really been wonderful. It's a great story.
Thank you so much. Sorry it took a little bit more